Hello, grade sixes, and welcome to your mathematics for today, brought to you by WorksheetCloud.com. I hope you guys are well and have had a good week. This is your last maths lesson for the week, so let's give it a really good shot. Listen carefully, make sure you understand. If you guys have any questions on this lesson or previous lessons, or perhaps there's a topic I haven't covered yet that you need to ask questions about, then please feel free to email me at the email address on your screen right now, which is grade6@worksheetcloud.com. Just a reminder that on worksheetcloud.com you have access to previous lessons that we've done. You also have access to activities and memos that are linked to each lesson, so you can go and do some additional practice in your own time. Okay, so today what I have for you is our normal start, your warm up and your mental maths questions, which are based on previous lessons. We're going to look at decimals today. I know we've done adding decimals before, but today we're going to delve into decimals a little bit deeper, what they are, why we use them, how we make them. So yeah, listen carefully and make sure you understand everything there is to understand about decimals. And then we have your brain bender and your maths challenge at the end. Okay, so there's your warm-up activity today. Some interesting characters in that puzzle. I'm not too quite sure who they are or where they come from, but you should know that by now that you need to work out the value of each symbol, and then remember to work out the value of the question mark at the end. Right, off you go. Good luck. Right, guys, I hope you managed to work through that okay. So I'm just going to get into the puzzle. So at the top of the line, we've got something we haven't actually had before. While I appreciate that the pink-haired icon is the same throughout, we've got one icon plus two icons plus three icons. So we can't split them into three even groups. So what we need to do is we need to take that 102 and we actually need to divide it by 6. And if we divide 102 by 6, we get 17. So we have 17 plus 34 plus 51, and that's going to give me a grand total of 102. Okay, then below that we know we need to add 34. Okay, and what plus 34 is 178, and that's 144. So what times what is 144? So the same number multiplied by itself, and that's going to be 12 times 12. And I know you guys know that because you know your multiples so well from previous years. Then below that is going to be 6 multiplied by 6. Okay, so what multiplied by 6 and then multiplied by 6 again is giving me 360. So we know 6 multiplied by 6 is 36. So it must be 10 multiplied by 6 and then multiplied by 6 again. That's going to give me 360. And then the last line will be 34 multiplied by 10 and multiplied by 12. Okay. And now here you can choose what order you would like to do this operation in. You can say 34 times 10 is 340, 340 times 12. You can say 10 times 12 is 120, and then 34 times 120. So the order in which you do this last multiplication sum is entirely up to you. Okay. Ultimately, you're going to get the answer of 4,080. Okay, so well done if you work that out. A little bit different to usual, and as I've said, the challenges are going to start getting a little bit trickier from here on in. Okay, there are your mental maths questions for today. So a straightforward subtraction sum to start, where you'll have to carry and borrow. A long division sum. So in the previous lesson, I introduced you to a new way of doing long division, and that was through multiplication. So we're going to have another look at that. A question about dates. Then it's a little bit of lateral thinking in question number 4. and then just a recap of our of sums that we've done in previous lessons. So off you go and do those 5 questions. Don't rush through it. Don't panic about how long it takes. I'm going to be here when you press play again. Just make sure that you do it properly and that you understand what you're doing. Right, off you go. Okay guys, so well done for working through those 5 mental maths questions. Okay, let's get into them straight away. So 6,008 take away 463. So by now we should know how important it is to put the correct numbers in the correct columns. Okay, we know 8 minus 3 is 5. I have a problem here. I cannot take 0 and subtract 6. So I need to borrow from somewhere. The only place I can borrow from is this 6. Okay, so that number becomes 10. But I need to borrow from that 10 to put there. So this 10, we'll put it in a different color actually, becomes 9. Okay, and now I can say 10 minus 6 is equal to 4. I can say 9 minus 4 is equal to 5. And 5 minus nothing is equal to 5. Okay, we shouldn't really have a problem with those subtraction sums. Okay, then if the date is the 29th of July, what would be the date 1 week later? So here I'm trying to see if you guys know how many days there are in each month. Okay, so there are 31 days in July. So a week on from the 29th of July is going to be the 5th of August. And you're more than welcome to go check your calendar to see if I'm correct. So you needed to know that July is 31 days. So the 29th, 30th, 31st, and then 5 days into August. Okay. Then question 4, just using your, so I'm just going to put a square, 3a plus c to b and then 5, 9. Okay, so we know that these 2 blocks need to be the same. We know, and that one needs to be the same. Okay, let's use a different color for A. And C is all by itself. Okay, so we can do a little bit of trial and error here. So what equals 9? We know that 5 and 4 added together is equal to 9. Now we know that the A's must be equal, so that has to be 4. That can be 1, and that can be 5. Okay? So that is a case of just plugging numbers in. In the units column, you might have used 6 and 3, but then you would have realized that that wouldn't have worked as soon as you got into the hundreds columns. So it is a case of trial and error until everything makes sense and everything works out. Right, and then the last question for tonight is 5 eighths. And we know that when we're dealing with fractions and we use the word of, it's multiplied, and 40 can be written as 40 over 1. So you have an option here. You can work out 1/8. Okay, 1/8 is equal to 5. So 40 divided by 8 is 5. And then 5/8 is going to be 25. So that's the first way you could have done that. Okay, you could have also looked at it and said, you could have made it a little bit simpler. We could have said 8 goes into 8 once and into 45 times. And then I've just got the 5 multiplied by the 5 equals 25. And 1 multiplied by 1 is equal to 1. And you know that any number over 1 is equal to that same number. Okay, guys, well done if you got those correct and if you've remembered them from previous weeks. I've just realized that I've left out question number 2. So let's get on with question number 2. My apologies about that. We as teachers, we are allowed to make mistakes every now and then. Okay, so if I've got 1,275 divided by 85, okay, I'm going to work this out by multiplication. So the first thing I'm going to do is 85 multiplied by 10 equals 850. I know if 850 is 10 lots of 85, I know that double 850 is going to give me more than 1,275. So I'm now going to have a look at 85 times 5. And I don't really have to work out what 85 times 5 is, because all I need to do is half the 850 to 425. Now if I add 850 and 425, I'm going to get 1,275, which is the number that I was dividing in the beginning. So how many times have I multiplied 85? I've multiplied it 15 times. 10 and 5. So that answer is therefore 15. Okay, now I'll continue to do some of these problems as we move on because they don't all work out perfectly. But I just think again, guys, that working out division using multiplication, especially when I can multiply by 10 and then halve it, makes it actually quite straightforward. Okay, decimals. So a little bit of a quick recap. What are decimals? Decimals are numbers that have a decimal place, which is normally indicated by using a comma. Okay, how do we get decimals? We get decimals by dividing the numerator of a fraction by a denominator of a fraction. So for example, 1 over 2, which is a half, 1 divided by 2 is 0,5, which is a decimal. Okay, and then when do we use them in real life? And I've just added some pictures in there. This picture over here is a temperature, like a thermometer that gets hold to your forehead, and that says 36,5. That's a decimal. This is a gadget that measures the amount of light in the atmosphere, and that has a decimal. We have decimals involved with money. So for example, 2 Rand 55, it's 2 Rand is 2 whole numbers, and then 55 is 0,55. That's a decimal. Okay. At the bottom here, we have a speedometer from a motor vehicle, and you can see the little numbers in there measuring distance. I think it's 554,1 kilometers or miles or whatever it is. That's decimals. And then I've also put in another temperature gauge at the bottom, which involves decimals again. So, guys, there are decimals all over the place. Okay, on a stopwatch, when you're recording the 100 meters, is a decimal, 9,69. You know, it's 0.69 is a decimal. So there are a couple of examples of decimals and where we use them and how we get them and what they are. A decimal is the same as a fraction. It's a type of fraction. Okay, it's also part of a whole. All right, so a half is the same as 0,5, and 0,5 is part of a whole number. Okay, so decimal is just another way of writing a fraction. Okay, so what I've put on the next screen for you is when we write decimals, we follow this place order. So numbers before the decimal comma are whole numbers. So numbers to the left of the comma are all whole numbers. So you know that in the example on the screen is 2,256. The 2 units, those are 2 whole numbers. Okay. The number on the right of the decimal, the tenths, that is a fraction. That's 2 over 10. The 500ths, that's 5 over 100. The 6,000ths, that's 6 over 1,000. So if I go to my Google Jamboard and I put up the same diagram, this 2 is 2 multiplied by 1, and we know that equals 2. Okay? This 2 is 2 multiplied by 0, 1, which is equal to 0, 2. We could have also said that's 2 times 1 over 10, 1/10. Okay? So that's what your tenths column is equal to. Your hundredths column, 5 over 100, which is the same as 5 multiplied by 0, 0.01. Okay? And then your thousandths, if I just clear some space, your thousandths is going to be 6 multiplied by 1 over 1,000, and that is equal to 0, 0.006. So those are the values of the units, the tenths, the hundredths, and the thousandths. Okay, really important for you to understand that numbers to the right are smaller and numbers to the left of the decimal place are indeed bigger. Okay, so in this example at the bottom of the page, I've asked you what is the value of the numbers in bold. Okay, so go ahead and write out 5,892. Put the 5 in the correct column, the 8 in the correct column, the 9 in the correct column, the 2 in the correct column, and do the same for B and do the same for C, and let's see how you guys get on. Right, off you go. Okay, guys, so are those the 4 examples? I don't think those are the 4 examples in front of you. So what I'm going to do is I'm going to have a look at them here quickly. Okay, let's just wait for it to clean. Okay, so the first one that we had, and if I just go back to that screen, is 5,892. We also had 13,05, and then we had 763,22. Okay, so if I go back to my Jamboard, right, so this is 5 units, right? The 8 is 8 tenths. Okay, now recognize that it's spelt with a THS on the end. In fact, all the numbers after, or all the numbers to the right of the decimal are spelled with THS on the end. The 9 is 9 hundredths. And the 2 is 2 thousandths. THS. Okay. So what do those look like without the words? Right, so 5 units looks like the number 5. The 8 tenths looks like 0, 0.8. All right. The 9 hundredths looks like 0, 0.09. And the 2 thousandths is 0, 0.002. Okay. And they asked you what the value of the 9 was, because the 9 was in bold. So the 9 is going to be 9 hundredths. Okay. 13,5, right? The 5 was in bold. So here what I'm looking at, okay, we know that it's 1 times 10, 10, 3 times 1. We don't have to worry about the 0 because it's not worth anything, it's got no value. But then we have 5 times 1 over 100, which is 0, 0.05. Okay, so those are the values of 13,05. They asked you what the value of the 5 was, 5/100ths. Okay, and then the last one was the 7 was in bold. Okay. All right, so we know it's 7 multiplied by 100, 700. 6 multiplied by 10 is 60. 3 multiplied by 1 equals 3. Okay, then we have 2 multiplied by 1/10. 1/10 is the same as 0,1, so that equals 0,2. And then 2 times 1 over 100, which is 0,01, and that answer is 0,02. Okay, so I've just expanded those decimal numbers just to show you how they are composed and how they're put together and what the value of each individual digit is. We all know that the value of the numbers to the left of the decimal. It's the numbers to the right of the decimal comma that are smaller than 1 and are either 10th, 100th, or 1000th. Okay. And obviously the 7 that was in bold is worth 700. Okay, so I'd like you to go ahead and just do the top 4 A, B, C, D. I would like you to write those numbers and words as a decimal by themselves. Okay, then we'll get into the rest of the work. So off you go and fill in those top 4 questions, please. Okay, guys, so well done on completing those 4 questions. So this is just a case of knowing what number goes into what column after the decimal. Okay, so we know that 6/10, and let's try and increase this a bit. Okay, we know that 6/10 goes in the 10th column. We know that 700ths goes in the 100th column, and 4,000ths go in the thousands column. So that's tenths, hundredths, and TH for thousands. Okay, B is just another way of writing 432 thousandths. Okay, so what you need to look at here is how many times does 1,000 go into 432? Because 432 over 1,000 means 432 divided by 1,000. So 1,000 doesn't go into 432, so it's 0. And then what's left over is 432. Another way of looking at it is, so we have 432. Another way of looking at it is saying, how many zeros are there in the denominator? There are 3 zeros in the denominator, and that tells us how many numbers there are after the comma, after the decimal place. So it's 1, 2, 3 numbers, and there's 1, 2, 3 zeros. Okay? So for C, it's 4/10ths, 900ths, and 3,000ths. We could have also written that as 493 over 1,000, 3 zeros in the denominator, 3 numbers after the decimal. So we do the same thing here, 3 zeros in the denominator, 3 numbers after the decimal place, and those numbers are in the numerator. Okay, and guys, that's pretty much what it is. Okay, we move on to rounding off. Okay, now rounding off of decimals, if I'm rounding off to the nearest 10th, which is what the first 6 questions ask you to do, if I'm rounding off to the nearest 10th, I look at the 100th place. Okay, if the 100th place is 5 or greater, then the number in the 10th column goes up 1. If the number in the 100th column is less than 5, the number in the 10th column stays exactly the same. So looking at these questions, and I'll do A and B for you or with you. 67,23, we're rounding off to the nearest 10th, which is the first number after the decimal place. So we look at the 100th column, which is 3. It's less than 5, so it remains 67,2. Okay, B, we're rounding off to the nearest tenth, the first number after the decimal place. So we look at the 100th column, which has 7. That's greater than 5. So your 10th digit goes up 1. Okay, 48, 1. A little bit of a small 1 there. Sort it out there for you guys. Okay, so go ahead and do C, D, E, F. And then we'll look into rounding off to the nearest 100th. So let's see how you guys did with those rounding off questions. So I'm rounding off to the nearest tenth. So for C, I look at the 100th column, which is 8, which is greater than 5. So that becomes 124, 8. Okay. 90,14. I look at the 100th column, which is 4, which is less than 5. So it remains 90, 1. E, 54,53. I look at the 100th column. It's less than 5. So my 10th column stays the same. And for F, 7,06. I look at the 100th column, which is 6, which is greater than 5. So my 10th column goes up 1. Okay, when we're rounding off to the nearest thousandth, when we're rounding off to the nearest 100th, we look at the 1000th column. So by now you should have realized that whatever we're rounding off to, we look at the column to the right. So the same thing applies. 58,127, I look at the 1000th column, which is 7, which is greater than 5. So the 2 in my 100th column goes up 1, and it becomes 58,13. Okay? You guys go ahead and do B, C, and D. Okay, let's have a look and see how you guys got on. So for B, I'm rounding off to the nearest 100th, which is 4. I look at the 1000th column, which is 5. So my 4 needs to go up to 70,35. Okay, for C, I've got 45,007. I'm rounding off to the nearest 100th, which is the second number after the decimal. So if I'm rounding off to that second number, I look at the third number, which is 7, so greater than 5. So 45,01. And for D, 78,134. I'm rounding off to the nearest 100th. I need to look at the 1000th column. It's less than 5, so my number remains the same. Okay, I hope that makes sense to you guys. If not, replay this video, go over it again. If you're still unsure, send me an email and I'll get back to you as soon as possible. And a reminder, that email address is at the bottom of your screen, grade6@WorksheetCloud.com. Okay, well done. That was our decimals for the day. Here's your brain bender. Go ahead and work it out. I thought it was a nice little theme considering the situation we find ourselves in. So a little bit of love, peace, happiness, and a bit of free spirit to get us through the next 2 weeks. So go ahead and work out the value of those symbols, and let's see how you guys get on. So let's see how you got on. The way I approached this puzzle is I just decided to put numbers in to see if they would work. So I recognized that the middle column had multiples of 3 in it. So I put in the number 3 for the little Forksy bus. And that means that's 3 and that's 3 because they're all the same symbol. Okay. Then I said 12 multiplied by 3 is equal to 36. All right. This 3 multiplied by what is equal to this 15. So that has to be 5. Okay. And if that guitar is 5, then this guitar must be 5. Okay. Then I had a look at 0 over here. Okay. And I just was interested to see if it would work. So if that dove, that peaceful dove is 0, then those must be 0 as well. Okay. The globe or the earth with a heart on it must be equal to 12 times 5, which is 60. Okay. And then the peace sign has to be 1 so that 1 times 0 is 0, 1 times 3 is 3, and 1 times the 5 is equal to the 5. Okay, so I didn't get that first time. I had to play around with it a little bit, and if you had to do the same, then well done for sticking with it and getting there in the end. Okay, guys, all that's left for me to go through with you today, or to leave you with today rather, is this challenge. Again, you should be used to it, and the reason I like this game of 24 is because it really gets you to play with the numbers and learn about the order of operations and use numbers flexibly. Remember, the numbers are there for your use. They are in service to you, so you need to use them however you can and however it benefits you. So don't be afraid to play around with the numbers, especially at such a young age. Break them up, put them back together again, see what they work with, how they work with other numbers and other operations, and see if you can get 24 on each card, and see how many times you can get 24 differently. That for me is the second part of the challenge. Guys, thanks very much for listening in today. Have a great weekend. Keep safe with your families. If you can get a little bit of exercise in the mornings, that's going to do you the world of good. And it's really important for you guys to stay on top of your studies and your academics, and use WorksheetCloud for science, English, maths, and just have a look at the activities and the memos, and really grab the opportunity with both hands to improve your studies and your academics. And hopefully by the time we get back to school, it's going to be as if you haven't missed a single lesson. Guys, stay safe, keep well, and have a great weekend. All the best. Cheers.